Hello dear students, this video is for standard 9 and in this video we are going to discuss chapter 8 which is motion. So with the start of chapter we have to understand about motion. What is motion? You can give one word to motion as movement. Movement means change in position. So if there is change in position with respect to time, an object is said to be motion. जैसे आप एक बार कंसिडर करो कि मैं अगर एक जगह से दूसरी जगह पोजीशन बदलता हूँ, ठीक है, तो जब तक मैंने अपना पोजीशन चेंज किया है, जितने समय तक मैं एक जगह से दूसरी जगह तक जा रहा था, मोशन में था, कंटिन्यूअसली पोजीशन चेंज कर रहा हूँ, तब तक मैं मोशन में हूँ. जैसे ही मैं रुकता हूँ, आई एम एट अ स्टेट ऑफ रेस्ट. Okay, so when an object does not change its position with respect to time, means time passes and the object is at the same position, that state is called state of rest. And the state where an object is continuously moving with respect to time, means there is some change in position, continuous change in position is observed, then that object is said to be in motion. That state is called as a state of motion. So when an object is in motion, it certainly moves on a certain path, and the path of that the length of that certain path is called distance. So motion, for motion you can give one word as movement, or you can say change in position. Change in position indicates that an object has gone through motion or it has experienced some motion movement. Okay, now if it has followed some path, then that path must have some length. That length of that path is called what? Distance. So you can say that length of actual path on that the object is traveling. Length of actual path. Let it be a position A where an object is there, okay, and that object moves on this straight line and reaches to a place B. So during that, in that duration, this object is in motion and it has changed its position from A to B along this path. So the length of this path is what? Distance. But one more thing you have to consider, and what is that? That for reaching B, means for this destination B, is it always essential that there is only one way? No. कितने भी रास्ते हो सकते हैं, जरूरी नहीं कि ए से बी तक जाने के लिए केवल एक ही रास्ता होगा, कई सारे रास्ते हो सकते हैं और जितने भी रास्ते होंगे हर रास्ते का जो लेंथ है वो अलग अलग हो सकता है. यानी एक पॉइंट से दूसरे पॉइंट तक जाने के लिए डिफरेंट डिस्टेंस हो सकता है. मीन्स दिस डिस्टेंस कैन बी वेरी बिटवीन टू पॉइंट्स. डिस्टेंस कैन वेरी बिटवीन two destinations. But there is another term which is displacement. This displacement is also a kind of distance which does not change between two positions. Means अगर किसी पर्टिकुलर डायरेक्शन की बात करें, यानी ये जो ऑब्जेक्ट है वो एक पर्टिकुलर डायरेक्शन में बी की तरफ चला है और बी तक पहुंच गया, ठीक है, कहीं उसने डायरेक्शन चेंज नहीं किया है. तो ये जो डिस्टेंस होगा वो उसका डिस्प्लेसमेंट कहलाएगा. You can define displacement as the shortest, the minimum distance between two points which can never change. That distance is called what? Displacement. So displacement is, it doesn't mean that whether how many paths are there. मान लो कि इस ए से बी तक जाने के लिए बहुत सारे रास्ते हैं, लेकिन इससे डिस्प्लेसमेंट को कोई फर्क नहीं पड़ता है. डिस्प्लेसमेंट का मतलब है रास्ता चाहे जितना भी हो, कोई भी रास्ता हो, उससे कोई मतलब नहीं है. उसका लेंथ क्या है उससे भी उसको कोई मतलब नहीं. उसको मतलब है केवल इनिशियल पोजीशन में और फाइनल पोजीशन में, उन दोनों के बीच में किसी एक पर्टिकुलर डायरेक्शन में कितना डिफरेंस है, कितनी दूरी है. अभी आप समझ रहे होगे कि केवल इनिशियल और फाइनल पोजीशन को देखना है, ठीक है. बट वहां आपको देखना है क्या, डायरेक्शन भी सही होना चाहिए, कहीं दूसरे डायरेक्शन से नहीं, किसी एक पर्टिकुलर डायरेक्शन में जो मिनिमम डिस्टेंस होगा वो होगा डिस्प्लेसमेंट. तो इसको आप लिख सकते हैं लेंथ ऑफ शॉर्टेस्ट पाथ विथ डायरेक्शन. मीन्स डायरेक्शन मस्ट बी देयर. और यही बात जिसके कारण डिस्प्लेसमेंट डिपेंड्स ऑन डायरेक्शन, फॉर दिस इट इज ऑल्सो नोन एज अ वेक्टर क्वांटिटी. इट इज अ वेक्टर क्वांटिटी. Why? Because it depends on direction, whereas this distance is a scalar quantity. And this displacement can never change. It always remains same, always same between two destinations. Okay, these 3 points of differences are there between distance and displacement, but the unit are same. We use meter or kilometer for distance, measuring distance, and displacement is also measured in the same unit. Okay, now this is what, this is all about distance and displacement. Now think of a condition that an object is there or a car is there which is covering different distances. Its rating is given as time is mentioned. Let it be 10:20, 10:30. Let it be 10:21, 10:22, 10:23, like this. And distance covered by it is, at 10:20 it has covered, it was at 100 meters. At 10:21 it shows 150 meters. At 10:22 suppose it covers, it shows 200 meter, and here it shows 250 meters. So what is the difference between the two time intervals? Time interval is of 1 minute. Here it is also 1 minute, 1 minute. So in 1 minute, what is the difference between the two distances? 50 meters. These two also 50 meters, these two also 50 meters. So in each interval of time, means in every minute it is covering 50 meters. First minute it is covering 50 meters. In the next 1 minute again 50 meters, and the next 1 minute it is also covering 50 meters only. So if an object in such kind of a motion where it is covering equal distances in equal interval of time, it is called what? it is called to be in uniform motion. Such motions are called uniform motions, where object always cover equal distances in equal interval of time. इसी जगह पे अगर ऐसा होता that this 1 minute, first 1 minute it is covering 100 to 150 means 50 meters, and it would have been 210 meter, and this would have been on, let it be 250 meters only. Then what would be the difference? This is 50 meters, here we find 60 meter, here we find 40 meters. Here we can observe that in the first 1 minute it has covered 50 meters, in the second 1 minute it is covering 60 meters, and in the third 1 minute it is covering only 40 meters. Means in equal interval of time, means time interval is of 1 minute only, but distances covered are different. Such motion are called as non-uniform motion. Okay, now we are going to see this, as we have done what? We have done measurement of what? Measurement of motion. So when we go to measure the motion, measure the rate of motion, we come through these speed, velocity, acceleration, these terminologies. Speed is what? Speed can be called as measurement of rate of motion. Why is it called rate of motion? Motion means change in position. Motion means change in position. So and if more position is changed, it means distance is covered. So distance is covered, but with respect to what? With respect to time. So the rate of motion with respect to time, which is the ratio of distance and the time taken, is called as speed. We give another physical quantity, that is speed. So you can define speed as distance per unit time. If this time becomes 1 unit, let it be 1 second or 1 hour, then the distance covered in that 1 minute, 1 second or 1 hour is called what? Speed. Okay. Now what is velocity? See, speed is what? Only distance by time. How much distance is covered and for what time it was in motion. So in the previous example, as it was traveling from 10:21 to 10:23, 10:20, 10:22, at this time it was covering 100, it was at 100 meters. 10:21 it was showing 150, at this one 200, 250, like this. So for finding the distance, for finding the speed, what do we have to do? We have to measure the time for which object is in motion. Here 1 minute, here also 1 minute, here also 1 minute. So total time is what? 3 minutes. And how much distance it has covered? Here 50 meters, 50 meters and 50 meters. Total 150 meters. So if we want to know the speed of this object, that per minute how much distance it is covering, what do we get? We get 50 meters per minute. So this 50 meter per minute is what? Speed of that object. See, SI unit of speed is actually meter per second. So to convert it in its SI unit, you can divide it by 60, because 1 minute contains 60 seconds and you will get meter per second. Hence it will be 5 by 6 meter per second. Okay, up to this is clear. Now what is velocity? Velocity is nothing but speed. What kind of speed? Speed with direction. Speed does not concern with the direction, but this velocity is concerned with direction. So you can define velocity as speed with direction. And how can you define acceleration? Acceleration can be defined as rate of change of velocity. Rate of change of velocity. So let us understand this. This is what change of velocity. What does it mean? It means that an object has some different velocity initially, and after some time it gains some velocity, it attains different velocity. So let there be an object which is initially, this is velocity and this represents time. This is what origin means. At this time means at 0 second, when time is not started, the time is not observed when object was in motion, but we were not observing that. When we started observing, it was moving with some velocity, let it be u, and after that it continues to be in motion and its velocity increases by the time increases. So with increasing time, its velocity is increasing. Okay, so what can be the change? Let it be time t. After time t, it has moved up to this point. So we are considering this point after t seconds. So after t seconds, how much velocity has been changed? See, it has reached up to here. Let it be v. So how much change is there? So this total value is v, and up to this is what? U, initial velocity. So how much change is there? This is the change from here to here. This is the change, and this can be determined as change in velocity, that is v minus u. So this is what? Change in velocity. And with respect to what? Rate means here always rate means with respect to time, whether the rate of motion or the rate of change of velocity. So rate means with respect to time. So here change in velocity is v minus u, and rate means with respect to time. So it will be divided by t. Acceleration is denoted by a small letter a. Hence we find a formula, that is a is equal to v minus u by t for acceleration. This is the relation between acceleration, velocities and time. So if this change in velocity remains the same after each interval of time, means let it be in first second the change in velocity is 5 meter per second. In the next 1 second it again changed to 5 meter per second. Means for the first second if it was moving at 5 meter per second, in the second Second time it was observed, it was moving with 10 meter per second. After that, in the third second, it was moving with 15 meter per second. In the fourth second, its velocity becomes 20 meter per second. So what do we observe here? We observe that after each second, the velocity is changed by 5 meter per second. Here is the change is 5 meter per second, 5 meter per second, 5 meter per second. Means in each second, the velocity changes by 5 meters per second. Such kind of acceleration produced in an object is called uniform acceleration. And if this change in velocity changes in every interval of time or any equal interval of time, then the acceleration produced is called as non-uniform acceleration. One more thing you must consider, that acceleration can be zero. Why? Because if velocity is constant, if velocity does not changes, at that time change in velocity will be zero. For understand this from a graph, let it be velocity, let this represent time, and velocity is constant. What does it represent? It represents that time is changing, but velocity is constant. Velocity is never changing. So this represents constant velocity. In such a case, if we find, let it be first second, 2 second, 3 second. At first second it is, if 10, for second it is also 10, third second it is also 10, fourth second it is also 10. Means the time is changing but the velocity is constant. So in this case, change in velocity will be what? Zero. If it is so, then the acceleration will be zero. So acceleration can be positive, acceleration can be zero, and one more case is there in which what do you find? You find that velocity continuously goes down, hence decreases. When it happens? It happens when brakes are applied. When the driver or the pilot applies brake, the velocity continuously decreases, and in that case the final velocity will be less than the initial velocity, and this v will be smaller than this initial velocity, and in that case this change will be negative. And if this change will be negative, the ratio will also be negative. So in that case we find a negative acceleration, which is termed as retardation. So you can say that retardation is nothing but negative acceleration. Negative acceleration is also termed as retardation. So this graph indicates negative acceleration. This indicates zero acceleration, and this indicates positive acceleration. So what do we find here? We find that acceleration can be positive, zero, or negative. Okay, so in this chapter or in this class we are going to understand up to now only. In the next class we shall study the further topics, like we shall study how to represent motion of an object graphically, and what kind of equations of motion can be derived from those graphs, or how can we derive those equations with alternate methods. Okay, till then, thank you, keep watching